In May 1952, an event that would change our lives was unfolding. In a damp, slightly dark basement laboratory at King's College in London, time seemed to have stopped. There was a faint smell of ozone in the air and the endless hum of high-voltage machines. Rosalind Franklin was focused on a strand of DNA, thinner than a human hair, suspended inside an extremely delicate glass tube she held in her hands. Even a single mistake could throw away days of work. For a full 100 hours, X-rays were sent continuously onto that thin strand. Rosalind knew that the radiation was silently penetrating her cells, but she did not stop. Finally, she turned off the machine, developed the film, and saw the image that appeared at that moment, Photo 51. Why do you think Photo 51 is so important? On a black background, a perfect X shape spreading outward from the center. At that very moment, Rosalind realized that the deepest secret of life, the helical structure of DNA, was right before her eyes. But this victory would cost her life. Now let's see what Rosalind had been through. Rosalind was born in 1920 in London into an elite, traditional, and wealthy Jewish family. The path planned for her was clear: a good marriage and work in social charity. But Rosalind's mind worked differently. Even as a child, instead of playing with dolls like her friends, she preferred solving arithmetic problems and doing carpentry work. Her father believed that a woman becoming a scientist was an unnecessary adventure. But Rosalind's determination and curiosity eventually broke through her father's authority. When she entered Cambridge University, it was a time when it was difficult not only for women to become members of the university, but even to begin studying there. In the laboratory, she worked harder than many of her male colleagues. She desperately wanted to solve the perfect geometry hidden in the arrangement of atoms. When World War II began, her research on the structure of coal provided critical information to the British Navy. But in Paris, she discovered the love of her life, something that would eventually lead to her death: X-ray crystallography. There, she learned how to fire X-rays at a substance and map its atomic structure from the shadow it produced. She now possessed the power to see the unseen. When she returned to King's College London in 1951, she was treated like a stranger. Her laboratory colleague, Maurice Wilkins, did not see her as a fellow scientist because she was a woman. Instead, he treated her more like an assistant assigned to him. Rosalind was also excluded from the academic environment, where dinner halls were reserved only for men. But instead of worrying about these situations, she focused on her work. And as a result, using X-rays, she managed to see the model of DNA, Photo 51, while Watson and Crick were trying to build a model of DNA in Cambridge. They had no concrete data in their hands. They were mostly making educated guesses. But one day, without Rosalind's knowledge, her colleague Wilkins betrayed her by showing the famous Photo 51 to James Watson. When Watson looked at that image, everything he had been searching for was suddenly right in front of his eyes. The helical structure, which Rosalind had spent months working on, carefully calculating and analyzing with mathematical precision, had been taken to their desk almost like a theft. While Rosalind was still writing her paper proving that DNA had a double helix structure, Watson and Crick had already finished their own model by adapting her data, and their discovery quickly shook the scientific world. Rosalind's data was published in the same journal, but only as a supporting addition to their theory. No one realized that she was the true architect behind it. Rosalind Franklin never started a major public fight over this data theft because she was a woman. She simply continued her work without looking back and focused on solving the structure of viruses. But there was something she didn't realize. The intense radiation she had been exposed to in the laboratory was slowly demanding its price. In 1958, at just 37 years old, Rosalind Franklin passed away from ovarian cancer. When she died, the world still did not realize how great her contribution to DNA truly was. 4 years later, in 1962, when Watson, Crick, and Wilkins stepped onto the stage to receive the Nobel Prize, they did not even mention Rosalind's name. According to Nobel rules, the prize could not be awarded posthumously, but the truth has a way of revealing itself. Today, whenever we look at the double helix structure at the heart of modern biology, we are actually seeing the result of those 100 hours of work that Rosalind carried out in that dark basement laboratory, the same work that ultimately contributed to her death. She never received the prize, she never tasted the fame, but she went down in history as the eyes that first truly saw the structure of life. If it were not for her, perhaps we might never have understood the DNA double helix at all.